Welcome to the walkthrough of the Gravity Engine launch to orbit scene. This scene is in the Gravity Engine demos minigames folder. There are a few scenes here that are meant to be a kind of springboard to making use of Gravity Engine for the kind of common things you might want to do in a gravity-based game. The purpose of this scene is to show you how to, starting on the surface of the Earth, launch a rocket, adjust the rocket's attitude, and achieve orbit around the Earth or escape the Earth's orbit if that's what you're trying to do. So first, let's just do a quick walkthrough of how the scene works as a experience. So we'll press play. There are some instructions built in. So the goal is to launch to orbit. Space starts the engine or stages the engine. Orientation through the keys WASD. You can do time speed changes through the keys 1 to 5. And camera controls to spin the camera and zoom the camera are via the middle mouse button and scroll wheel or the arrow keys. In addition, there's an orbit camera, which you can get to by pressing F1, and the ship camera, which we're using now, is F2. So let's clear off these instructions. Go ahead and start. So we now have the rocket under acceleration. We can see that the velocity is increasing. The other thing the scene provides is this panel of information on altitude, velocity, and fuel use. And once we get to 50 kilometers, there will be another panel that appears that shows the parameters of the orbit, or lack thereof. So we're going to now start pitching over here. We're going to up the time scale a little bit by pressing 3. So in order to achieve orbit, you need to make sure that most of your thrust goes into attaining lateral velocity, because you need to move sideways fairly quickly so that as you fall, you don't hit the Earth. So we'll try and do this. And so we've hit 50 kilometers, and that purple line you see is the line from the orbit predictor. And I'm just going to pitch over a little bit. We can turn off the trajectory prediction with the T if we wish to. Just move that over a bit. Slow us down a little bit to a factor of 3. And now let's look at the spaceship camera. So we can see here just this little purple line. That's our path as we're starting to climb up, and we can see that our orbit in fact intersects the Earth, which is because this perigee here is not yet more than 6,500. So if we go back to our spaceship view by pressing F2, let's add a little more horizontal velocity, and then we'll just pay attention to this perigee. If we go back and look to the orbit scene, you can see that our orbit is in fact just about attained. We're not going to hit the Earth in just a few minutes. Do a little more pitching over. We're going to be a little bit more elliptical than would be ideal. And there, we are now no longer going to collide, so let's just ditch that stage. I hit space, we have engines touchdown. If you zoom in here, oops, so much, you can see that the stage is falling behind. If you go to the ship view, you can see that we're zooming along on our trajectory. So we'll just pause there. So in this scene, we obviously have an Earth. We have our gravity engine. Notice here that the units are set to orbital because we want to take advantage of the actual mass of the Earth and the actual radius of the Earth. So that means our units are kilometers, 10 to the 24 kilograms in hours. So when we look at our spaceship, its position of 6,371.8 kilometers is roughly the radius of the Earth, just outside the radius of this sphere I've created. And then the thing that makes this entire thing possible is this script here, the multi-stage engine script. So there's a new family of classes in Gravity Engine 1.6 that extend a base class called Rocket Engine. And the way the rocket engine works is an acceleration is added on every integration time step. This ensures that you get a very smooth trajectory, so you're not just giving it a kick every once per frame while the integrator runs 8 or 10 times per frame. It's as smooth as it can be. And the way in which the acceleration is requested, it's requested for an acceleration at a particular time, which allows the trajectory prediction to ask what the acceleration would be at future times, i.e. has the engine shut off yet. Also, as time goes forward, the fuel is consumed, and so the mass of the fuel goes down, the overall mass of the engine goes down, the same thrust applied to the lighter spaceship makes it accelerate slightly faster, so that's all taken into account in the way these rocket engines are implemented. The specifics for a given stage in the rocket engine allow you to use consistent units, SI units, for the empty mass of the stage, the mass of the fuel, the burn rate, and the thrust. The thrust is currently constant. It's not absolutely accurate for rockets thrusting in an atmosphere, but it's a really good first start. So the space bar, when you first press space to launch, is code that runs in this launch controller, and there's a script called launch UI. And inside that script you will find the code that handles all of the key events, with the exception of the time zooms, which are handled in a separate time zoom script, which is down here, and the camera controls, which are attached to the camera object itself. The mission camera, which is up here. You can see the camera spin script. So if you need to look at the code for how the rocket engine is started and how you call into it to do engine on, going into the launch UI script is the right place to start on that thread. It also has some hooks into the stages. Initially, the rocket is considered a single N-body, but as a stage event happens, the stage that is dropped now becomes its own N-body and is dynamically added to the gravity engine so that it can fall behind and its path can be seen in the scene. Again, the code for that is in the launch UI script, which is where you would want to look for that stuff. There are then some fairly simple scripts. The ship info script simply pulls out the appropriate time, position, altitude, and attitude information and renders it. And there's a similar script that does those things for the orbit. That's a very quick overview of this scene. I hope it gets you started on whatever project you have in mind. Thanks for your attention.